Okay, so today we'll be performing the chamfering operation, and this is a tutorial on Catia V5 on the chamfering operation. So first we go to start, mechanical design, part design, and we enter the name of the part. Let's say chamfer is our name. Okay, so we obtain this window, and for this tutorial I'll be using the YZ axis. You can use it, you can select it manually or select it from these three options on the left hand side. And now we go to the right hand side and press sketch. So now we're in the Cartesian coordinates, and I'll be using the profiling function to create a L-shaped joint like structure for the chamfering operation. So we have this. Yeah, so we have this L shape, and now we exit the workbench, which is on the right hand side. So we have this, and now what I'm going to do is I go down to the search bar on the bottom right and I type C colon pad. This is the padding function, and as you can see, this L-shaped joint like structure is being formed. So I'll change it to 40 millimeters so that we have some room to work with for the chamfer function. Press OK. So now we have this L-shaped joint. Okay, and now to obtain the chamfering toolbar, it's basically in the dress up feature. So you go to toolbars, dress up features right here below constraints, hit OK, and you obtain this window. It has edge fillet, chamfer, draft, shell functions such as that. So for this tutorial we'll be doing the chamfer function. So select chamfer. As you can see, there are a few modes here. So first we'll use the length and angle mode. So let's say the length of our chamfer should be 10 millimeter at 45 degrees angle. And now it says objects to chamfer. So we can go ahead and select this edge and this edge and hit preview just to see what it looks like, and OK. As you can see, this is what the chamfer looks like. Now we can undo it by pressing Ctrl Z and chamfer again. Let's do length 1, length 2 instead. So basically for this, what happens is it uses the length as well as the height of the triangle that we'll be chamfering out. So let's try it. Let's put 10 millimeter here and 20 millimeter here. And objects to chamfer, let's put this edge. Preview. Okay. Now this is what it looks like. Let's try it again with a different edge. Length. Let's try height and angle with a different edge. So in our first option, what we used was the length one. Now we're using the height. So let's put 10 millimeter and 45. Let's make it 40 degrees. And objects to chamfer, let's say this edge and this edge. Hit preview and OK. See, and this is what the chamfer looks like. Okay, and another function to uniformly chamfer a whole surface can also be used. So let's say we're going back to this function, let's say 5 millimeter, and objects to chamfer. As you're selecting, you can see that you can select a whole surface. So let's say we're selecting this whole surface. Hit preview. Okay. As you can see, the whole surface has been uniformly chamfered. This is really useful and time efficient instead of chamfering one edge at a time. If you want to chamfer a whole surface, you can use this function. And that's it. Thank you. I hope you found this tutorial informative, and this is Aditya Santosh Kumar from Mechanical Engineering. Thank you.